press the bell icon on the YouTube app and never miss another update.
Hello children, welcome back to the video class. It's part 12 of organic chemistry, some basic principles and techniques. In the previous class, we discussed about the classification of organic compounds and based on the functional groups and homologous series. We defined homologous series and I have given the characteristic properties of homologous series. Today, let me explain the characteristic properties of homologous series. As we know that the characteristic properties of homologous series in which characteristics of homologous series. So, under the characteristics of homologous series, the first characteristic properties of homologous series is that they can be represented by a single general formula. Whatever the number of members present in a series, all the members present in a series can be represented by a single general formula. So, example for this is, let me give alkane series. So, all the members present in alkanes can be represented by using a single general formula, that is CnH2n plus 2, where the n stands for number of carbon atoms and it starts from 1 carbon. Because the first member, if you put the value 1 here, the first member of the series you will get CH4, second member of the series will be C2H6, n is equal to 2, C2, 2 2s are 4 plus 2, 6, C2H6, and the next member will be C3H8, C4H10. So, like that you will get all the members of the series when you take the general formula for alkane as CnH2n plus 2. So, this is the general formula of the alkane series. If we put the value of n is equal to 1, 2, 3, you will get all the members of a series as CH4, C2H6 and C3H8, C4H10. Like that you can write the members of the homologous series. And the second example let me give here, alkene series. So, in case of alkane series, what is the general formula? CnH2n is the general formula of alkene, CnH2n, where n starts from 2, 3, 4, 5. So, 2, 3, 4, 5, because the minimum 2 carbon atoms required to form double bond. So, double bond means formation of pi bond and a sigma bond between the 2 carbon atoms. So, 2 carbon atoms minimum required to form pi bond between the carbon atoms. So, therefore, 2 carbon atoms. So, what is the first member? So, put n is equal to 2, what you get? C2H4. C2H4 is the first member, ethene. Okay, then propene and then butene. So, like that you will get the members in a series. So, C2H4 when n is equal to 2, n is equal to 3, what you get? C3H6, n is equal to 4, C4H8. So, like that you will get the members of the alkene series by using the general formula. Now, third one you write alkynes. Alkyne series. So, in alkyne series, So we have a general formula. CnH2n minus 2 is the general formula of alkyne series. Again, n is equal to 2, 3, 4, etc. So it also starts with the 2 carbon atoms. So triple bond is formed between the 2 carbon atoms. So the compound will be C2H2 is the general first member of the alkyne series, that is ethine. C2H2. See here 2 2's are 4, 4 minus 2, 2. So now C3H4 and C4H6. So like that we will get continuously the members of the alkyne series. Not only the alkene and alkyne series, so we can also give the general formula for other class of organic compounds also. Once you know the general formula, you can write the members, all the members of the series of that particular organic compound series by giving the value of number of carbon atoms in terms of n. Okay, now let me give the next example here. The fourth example for a general formula. Fourth one, alcohol series. Alcohol series. Alcohol series. So how to get the general formula for alcohol series? So alcohols are derived from alkanes. So by using the general formula of alkane, we can get the alcohol series general formula. So here we have to remove one hydrogen and we have to replace the functional group of alcohols. What is the functional group of alcohols? The functional group of alcohols is OH, hydroxy group. In the last previous class I told what is the functional group of alcohols. It is OH. So by replacing one hydrogen by OH, you will get the general formula of alcohol series. If we remove one hydrogen from the general formula of alkene series, it will be CnH2n plus 1. We are removing one hydrogen and then we have to replace it by what? So OH group. So you can write it as CnH2n plus 1 OH. So this is the general formula of the alcohol series. Here the value of n starts from 1, 2, 3, 4, etc. Okay. Now you can also write this as CnH2n plus 2. You can retain it too because in a functional group of alcohol there is one hydrogen and you can write CnH2n plus 2 O. You can also write like this, but commonly we are writing the general formula like this because we can easily find out the functional group. So in terms of functional group you can write this. In terms of number of all the atoms, atoms of different elements present in a compound, in that way you can also give the general formula as CnH2n plus 2 O. That can also be written as a general formula for alcohol series. Now put n is equal to 1, 2, 3, what you get? It will be CH3OH, methyl alcohol, then ethyl alcohol, then propyl alcohol. So like that you will get all the members of the homologous series. Now let me give the fifth one after alcohol series. So let me take one more series here, aldehyde series. Let me take aldehyde series as a general formula. Right. So the next series, fifth one. So aldehyde series. Aldehyde series. Okay. So how to get the general formula of aldehyde series? So here what is the functional group of aldehydes? CHO. CHO is the functional group of aldehydes. Let us consider aldehydes are the derivatives of alkanes. Then how to write the general formula? By replacing one hydrogen by a CHO group. So we need to replace one hydrogen by a CHO group, means we have to reduce one hydrogen from the general formula of alkanes. So then what is the general formula of aldehydes? CnH2n plus 1 CHO. CnH2n plus 1 CHO. So, if you take this as a general formula, as we know that the first member of the aldehyde series, is formaldehyde, HCHO. To get that first member, the value of N stands from 0, 1, 2, 3. So, to get the first member of homologous series of aldehydes, so here we need to give the value of N from 0. You have to start it from 0 to get the first member of the aldehyde series, because already we have written the functional group CHO here. So, it is derived from the general formula of alkanes by using the functional group of aldehydes, that is CHO. So, in a functional group of, when a functional group is present in a general formula, then we have to take value of N from 0. So, if you put 0 here, C 0, H2 into 0, 0, but here it is 1, H1, 1H and HCHO, formaldehyde. Put N is equal to 1, what you get? CH3CHO, acetaldehyde you will get. Put N is equal to 2, then C2H5CHO. So, like this you will get the members of the aldehyde series. Not only like this, you can also indicate the general formula by taking number of the atoms of different elements present in a compound. So, we have carbon, hydrogen and also oxygen. So, we have to take total number of carbon, hydrogen and oxygen. In that way also we can give the general formula of aldehyde series. So, here we mentioned the functional group CHO. Another general formula for this is, so CnH2nO. CnH2nO is the general formula of the aldehyde series. Now, give the value of N here from 1, 2, 3, 4. So, if you write the general formula as CnH2nO for aldehyde series, you have to start the value of N from 1. And if you write CnH2n plus 1 CHO, you have to start the value of N from 0. Now, put N is equal to 1. C1 H2O, CH2O. CH2O can be written as HCHO, CH2O, CH2O, HCHO. First member of the aldehyde series is formaldehyde, that can be obtained by giving the value of N is equal to 1. HCHO, CH3CHO, then C2H5CHO. So, like that you can give the members of the aldehyde series. So, you remember either this general formula or this general formula. If you use this general formula, then the value of N starts from 0, and if you use this general formula, then the value of N starts from N is equal to 1. Now, the next one I can give the carboxylic acid, the series carboxylic acid series. So, the sixth example, I can take carboxylic acids series. Carboxylic acid series. So, if we take it as the carboxylic acids, if they are derived from the alkanes, then we can give the general formula as, so Cn H2n plus 1, replace one hydrogen by a functional group called COOH, by a functional group called COOH. So, here also COOH is there, and this is the functional group of carboxylic acids. So, therefore, by replacing one hydrogen from the alkane, I replace at the functional group COOH. Now, what is the value of N? Here also the value of N starts from 0, because the first member of the carboxylic acid series is nothing but formic acid. Formic acid containing only one carbon. So, therefore, the value of N starts from 0, 1, 2, 3, etc. and you will get COOH. When N is equal to 1, you will get CH3COOH. When N is equal to 2, you will get C2H5COOH. C2H5COOH. So these are the examples for the members of carboxylic acid series. Or else you can also write the general formula like this: CnH2nO2. CnH2nO is the aldehyde, CnH2nO2 is the general formula of carboxylic acid series. So if you write in this form, general formula, then the value of N starts from 1. Okay, then what is the members of the homologous series? Are HCOOH, CH3COOH, then C2H5COOH. So again you will get the same members of the homologous series. The thing is, here we are using the general formula is derived from the general formula of alkanes, and here we are giving the general formula in terms of atoms of different elements, total number of atoms of different elements present in a given compound. So these are the two general formulae that we can give for carboxylic acid series. So this is about the first characteristic properties of homologous series. All the members of the homologous series can be represented by a single general formula. Now, what is the use of writing general formula here? So we can easily get the members of the homologous series by using this general formula. So that means to say, so let me give the example here. So give the next member of C2H4. Give the next member of C2H4 if I ask means, just you have to add 1 unit of CH2 here. Then what you get? C3H6. And you know that C2H4 is the first member of alkene series. Alkene series first member is C2H4, ethene. The next member will be propene, that is C3H6. So in that way you can easily identify the members of the homologous series, because the general characteristic properties of the homologous series is that every successive members in a series are differ by CH2 unit. Every successive members of a series are differ by CH2 unit. So this is the second characteristic properties of homologous series. By using general formula of respective series, homologous series, and by using the second characteristic properties of homologous series as every successive members in a series are differ by CH2 units. So once you know the member of a series, then you can identify the next member of a series by adding a unit called 1 carbon and 2 hydrogen atoms, by adding a unit called CH2 unit, and CH2 unit is nothing but a methylene group. It is nothing but a methylene group. So the second characteristic properties of homologous series is that every successive members in a series are differ by CH2 units. So every successive members in a series are differ by CH2 unit. It is nothing but methylene group. What it is called? Methylene group. It is differ by methylene group. So it means to say, once you know the member of a series, you can identify the next member. For example, which is the next member of C3H7OH? Which is the next member of C3H7OH? You keep this OH as it is and add CH2 unit to this. Add CH2 unit to this. What you get? C4H8OH. What is this compound? Propanol. The next member will be butanol. So C3 to C4. Just to add 1 carbon and 2 hydrogen atoms, you will get the next member of the homologous series. Again, if you want the previous member, then you can get by subtracting the CH2 unit. So that will be C2H5OH. So you can give the every successive members in a series by adding the CH2 unit. So here the successive member can be obtained by adding methylene group, and this is the second characteristic properties of homologous series. Now, let us move on to the third property. Third property. So, before going to third property, let me give the fourth property here. Every successive members in a series are differ by 14 atomic mass unit in a molecular mass, or every successive members in a series are differ by 14 units in molecular mass. So, every successive members, for example, if you take C2H6, the second member of a alkane series, which is the third member of a alkane series, it will be C3H8, C3H8, and these two are differ by CH2 unit, correct? These two are differ by CH2 unit. When these two are differ by CH2 unit, one carbon means 12 atomic mass unit, two hydrogen atoms means 2 atomic mass unit, total 14 atomic mass unit, means these two members are differ about 14 AMU in the molecular mass. What is the molecular mass difference between every successive members in a series? It is 14 units. So, difference in the molecular mass is 14 units. So, this is because constantly every successive members in a series are differ by CH2 unit. Because of that reason, the difference in the molecular mass is also constantly 14 units here. So, difference in the molecular mass is also constantly 14 units between every successive members in a series. So, that is on the basis of this you can say all the members in a series shows, or it means to say every successive members in a series shows regular gradation or a gradual gradation in the physical properties. They show regular gradation in physical properties. So, regular gradation in physical properties. What do you mean by regular gradation? Since, as I said, the molecular mass, physical properties mainly depends on molecular mass, especially the melting point, boiling point and the density if we consider, and even the solubility. So, all these physical properties definitely depends on the molecular mass, but every successive members are differ by a constant unit in the molecular mass, that is about 14 atomic mass unit. Because of this constant difference in the molecular mass, they show regular gradation. What do you mean by regular gradation? Constant increase or constant decrease, or gradual gradation in the physical properties. Regular gradation or the gradual gradation is nothing but constant increase or constant decrease in the physical properties. So, let me give the example here. So, if we take the boiling point of methane, so let it be the boiling point of methane. This is not the true value, just I am giving the example. If the boiling point of methane is 34 degrees centigrade, then what will be the boiling point of ethane? So let it be 36 degrees centigrade. Then what will be the boiling point of propane? Now you can give the boiling point of propane on the basis of this, because difference in the boiling point will be 2 degrees centigrade. So, therefore, you can write 38 degrees centigrade. This is called regular gradation in the physical property. This is not the true value of boiling point, just I am giving the examples. So, if methane boils at 34 degrees centigrade, ethane boils at 36 degrees centigrade, then propane boils at 38 degrees centigrade, difference of 2 degrees centigrade in the boiling point. This constant difference in the boiling point is because of every successive members in a series are differ by a constant unit called CH2 unit, and it is nothing but a methylene group, and therefore every successive members in a series are differ by 14 atomic mass unit. It is also constant in molecular mass. So, this is the reason why all the members in a series, or every successive members in a series, show the regular gradation in physical properties. Did you get the reason for this? The reason for that is the constant increase in the molecular mass of every successive members is about 14 atomic mass unit. This difference is constant, therefore it shows a regular gradation in the physical properties. Next one, the fifth one is nothing but all the members of a series are prepared by using a common chemical method. So to prepare the members present in a homologous series, we are using common chemical method, or a similar chemical methods are used for the preparation of members of a series. For example, how to prepare alkanes? By the reduction of halogen derivatives. So once you take the derivative of methane, that is chloromethane, this is the halogen derivative of methane called chloromethane. So methane can be obtained by subjecting it to reduction. After the reduction of chloromethane, you will get methane. Similarly, then how to get ethane? By the reduction of chloroethane. So here the methane is obtained from chloromethane, ethane is obtained from chloroethane. Even you can use bromoethane. You can change the halogen derivative, but the method used for the preparation of alkane remains the same. The method used for the preparation of alkane remains the same. So that is about the reaction, the method, common method which is used to prepare all the members of a homologous series. This is one more important characteristic properties of homologous series. So we are using one method to prepare the compound, means first member of the compound, means all the members of the series can be prepared by using the same method, So reduction is the method to get the alkanes from the halogen derivatives of alkanes or haloalkanes. When haloalkanes undergoes reduction, you will get a respective alkane. Similarly, alcohols are obtained by the nucleophilic substitution reactions of haloalkanes. When haloalkanes undergoes nucleophilic substitution with aqueous KOH or the water or the alkali hydrolysis we can go for, then it results in the formation of respective alcohols. And where we have to consider which is the method that we are using. Definitely it is a common chemical method that we can use for the preparation of all the members of a homologous series. Okay, now the last one is what is the last property of homologous series? They show similar chemical properties. So as I said, molecular mass determines the physical properties. Similarly, the presence of functional group definitely determines the chemical properties. So chemical properties of the compound depends on the nature of the functional group. So it depends on the nature of the functional group. So depending on the nature of the functional group, we can give the chemical properties of members of a homologous series. As all the members of homologous series containing same functional group, they show almost similar chemical properties. For example, what are the characteristic properties of alkanes? So you can say the characteristic properties of alkanes are substitution reactions. They undergo substitution reactions. What do you mean by substitution? Substitution is nothing but replacement of one or more hydrogen atom of alkane by another atom or group of atoms is called substitution reaction. So especially the alkanes gives substitution reactions. What are the characteristic properties of alkanes, they are nothing but they undergo substitution reaction. What is the reason? The reason for that is alkanes containing carbon to carbon single sigma bond. As they are having single sigma bond between the carbon atoms, their characteristic properties are substitution reactions. But what are the characteristic properties of alkenes and alkynes? It is nothing but addition reactions. Addition reactions are the characteristic properties of alkenes and alkynes. What is the reason? The reason is due to the presence of multiple bonds. Multiple bonds means there is a pi bond between the two carbon atoms. When pi bond is present in a molecule means those bonds are easily available for the attacking reagent. They are easily available for the attacking reagents. Therefore, when a pi bond is present between the carbon atoms, maybe in the form of double bond or maybe in the form of triple bonds, they show addition reactions. So, addition reactions are the characteristic properties of alkenes and alkynes. So, what are the characteristic properties of alkanes? Substitution. Why? Because of the presence of single sigma bond. So, this is the functional group of alkanes. Presence of double and triple bond is the characteristic property, or presence of double and triple bond, that itself is a functional group present in a compound like alkenes and the alkanes. They show addition reactions. So, difference in the chemical properties due to the difference in the nature of the bond between the carbon atoms. So, single bond gives substitution, double or a triple bond gives addition reactions. So, the functional groups are responsible for the chemical properties of series, or the members present in a homologous series. So, as every member containing same functional group, definitely they show similar chemical properties. Similarly, if you move on to the alcohol series, the best characteristic properties, chemical properties of alcohol series is again a nucleophilic substitution reaction. We can say they undergo nucleophilic substitution reaction, alkanes undergo substitution reactions, and the alkenes and alkynes undergo addition reactions. So, all these characteristic properties depends on functional group present in the homologous series. So, these are the characteristic properties of homologous series. So, all the members of a homologous series are represented by a single general formula. Every successive members in a series are differ by CH2 units, that is methylene group. So, all the members of a series can be prepared by using a common chemical method, and every successive members in a series are differ by CH2 unit, that is methylene group. So, because of that reason, every successive members in a series are differ by the 14 units in the molecular mass, or 14 atomic mass unit in the molecular mass. Therefore, every successive members in a series show regular gradation in the physical properties, and the members of the series show similar chemical properties because the functional groups are responsible for the chemical properties. So, this is about the characteristic properties of homologous series. Okay. Now, let us move on to the next concept here. So, this is about the characteristic properties. You need to give definition of homologous series, examples for homologous series, and you have to give the characteristic properties of homologous series. The question may be for 2 marks here. If it is asked for 2 marks, it is only the definition. Definition may be asked for 2 marks. What are homologous series? So, give an example. You need to give one example for homologous series, and what are the characteristic properties of homologous series? That is also for 2 marks. So, minimum 2 to 3 characteristic properties that you have to remember. So, it may ask like that, what are homologous series? Give the characteristic properties of homologous series, and that question carries 4 marks. Okay. And this question is very important for your theory exam and for your competitive exam. So, they may ask, give the next member of the series by giving the one member. So you have to add only CH2 unit to that, then you will get the successive members of the series. Now let us move on to nomenclature of organic compounds. So move on to nomenclature of organic compounds. What do you mean by nomenclature of organic compound? It's nothing but naming of organic compounds. What do you mean by nomenclature? Naming of organic compounds. Naming of organic compounds are nothing but nomenclature of organic compounds. So there are two systems for naming the organic compounds. What are those? The first one is common name system. Common name system. And the second one is IUPAC system. There are two systems are there to name the organic compounds. Two systems are there to name the organic compounds. First one is common name system. Second one is IUPAC system. Common name system is also called trivial name system. It is also called trivial name system. Okay, common name system or the trivial name system. Now, let us consider the first one. What do you mean by common name system of naming the organic compound? So, let us consider the first one, common name system or trivial name system. Very simple. Under the system, the organic compounds are named. Organic compounds are named on the basis of source or history. So, organic compounds are named on the basis of source or the history, and that system of naming the organic compounds is called common name system or the trivial name system, and the names are called common names and the trivial names. When we are going to name the organic compounds on the basis of the source from which that compound is obtained, or on the basis of any history behind to get that compound. So on the basis, if we name the compound, means then that name is called common name or the trivial name. So example I can give here, HCHO, HCOOH. HCOOH is called formic acid. Formic acid. Its common name is formic acid. This common name is derived from the word formicus. It is derived from the word formicus. It is derived from the Latin word formicus. Latin word formicus. What do you mean by formicus? It means to say it is red ant. It is nothing but red ant. So, when red ants are subjected to distillation, whatever the distillation product that we get, it containing HCOOH, and hence the name is formic acid. Means the source for formic acid is red ant. So, therefore, the name of the compound HCOOH is formic acid. So, this is based on the source. The formic acid is obtained from red ants. This compound is obtained from red ants, and hence the name formic acid. The name formic acid is derived from the Latin word formicus. So, red ant stings alli formic acid irutte. Hagagi adu kachchidaga namage uri agutte nodi. So, a novu yake agutte andre because it leaves the formic acid. So, that is why the HCOOH is derived from the source called red ants, and hence the name formic acid. And the second example I can give here is CH3COOH. CH3COOH, and it is called acetic acid. It is acetic acid. Common name for this compound is acetic acid. It is derived from the Latin word acetum. Acetum means vinegar. Acetum means vinegar. So, therefore, the name is acetum, which means to say vinegar, and it is derived from the word acetum, and it is nothing but acetic acid. So, the source for acetic acid is vinegar. Therefore, the name is acetic acid. Similarly, butyric acid, because it is present in a butter, therefore it is butyric acid. The source for butyric acid is butter. Similarly, tartaric acid, tartaric acid, tartaric acid. So, tartaric acid is obtained from, what is the source of tartaric acid? Tamarind. Tamarind is the source of tartaric acid, and hence the name tartaric acid. Citric acid. Why we to call that acid as a citric acid? Because it is derived from the citrus fruits. So, on the basis of source or the history, if we give name to the organic compound, means then that name is called common name or the trivial name. Common name or the trivial name. So, while giving the common names for alkanes, so let me go with the next topic here. Common names of alkanes. Common names of alkanes. Right. Common names of alkanes. Common names of alkanes. Uses some prefixes. Some prefixes. So, common names of alkanes uses some prefixes. So, if we want to use this prefix, minimum carbon atoms required is 4. The alkanes containing 4 or more than 4 carbon atoms, in their common names, we are using some prefixes. So, therefore, common names of alkanes uses prefixes. Prefixes means prefix the name. So, prefix the word before the name is nothing but prefixes. So, while naming the alkanes according to common name system, we are using prefixes, and we are using these prefixes for those alkanes which containing 4 or more than 4 carbon atoms. So, these prefixes are used for the alkanes which containing 4 carbon atoms or the more than 4 carbon atoms. On the basis of those prefixes, we can classify the alkanes into 3 types on the basis of common names. So, we can classify it as N-alkanes. N-alkanes. What do you mean by N-alkanes here? N-alkanes are nothing but normal alkanes. Normal alkanes. So, if we use the small n as a prefix before the name of alkane, then those alkanes are called N-alkanes. Then, what is the speciality in that prefix N? So, what this N indicates? N indicates normal alkane. What do you mean by normal alkane? Consider CH3, CH2, CH2, CH3. CH3, CH2, 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 CH3. So, these are the 2 alkanes I have taken. You know that 4 carbon atoms are here, therefore it is butane. It is butane, and this one is pentane. Butane and pentane. I took the example of butane and pentane. Even one exception, to use this N-alkane, you can also use the member called propane. This is propane. This is exception to here. Only for N-alkanes, you can take the example of propane also. So, here while giving the name as butane or the pentane, we had to use the prefix called n, small n, and followed by the hyphen. To separate prefix and the name of the alkane, so we had to use hyphen in between prefix and the name, and we had to name this pentane as n-pentane, and we had to name this as n-propane. Why we had to use the prefix n here before the name of alkane? The reason for that is these alkanes are having straight chain of carbon atoms. As they are having straight chain of carbon atoms, we have to use the prefix n before the name of alkanes. Then what are n alkanes? N alkanes are nothing but the alkanes which containing straight chain of carbon atoms. Alkanes which containing straight chain of carbon atoms are called N-alkanes. If a given alkane containing straight chain of carbon atoms, then we have to prefix the name of that alkane by using the small n. Small n stands for normal. Normal stands for straight chain of carbon atoms. Okay, now let us move on to the second type of alkanes here. Second one is isoalkanes. Isoalkanes. So what do you mean by isoalkanes? What do you mean by isoalkanes? So let me give the example for isoalkanes here. So how to give the isoalkanes? I'll write the carbon chain here. 4 carbon atoms in a straight chain and 5 carbon atoms in a straight chain, and here 3 carbon atoms in a straight chain. Now, in case of isoalkanes, let me give the same members. I can write butane in this form. I can write butane in this form. Similarly, I can write pentane in this form. Pentane in this form. So now butane we can write in this form first, and now I have written the same butane in a different way, and this is pentane. I have written the pentane in this way. Molecular formula of both the compounds are same. Molecular formula is same. So look at the molecular formula, C4H10. This is also C4H10. This is C5H12. This is C5H12. But nature of the carbon chain is different. Nature of the carbon chain is different. What is the nature of the carbon chain? Let me give the carbon skeleton of this. So this is the carbon chain. So this is the carbon chain in this compound, and this is the carbon chain in this compound. Is it straight? No, this is not a straight chain of carbon atoms. This is straight chain. What is this chain called? Branched chain. Branched carbon chain. What is the nature of the carbon chain? It is a branched carbon chain. So whenever alkanes containing branched chain of carbon atoms, and that branched chain of carbon atoms, if it contains, what is this carbon? What is the nature of the carbon? So look at this carbon. This carbon is branched, correct? Look at this carbon is branched. What do you mean by branching? Having a branch below this, then it is this carbon is branched, correct? When this carbon is branched, what is the type of this carbon? This carbon is bonded to 3 other carbon atoms. Whenever a carbon atom is bonded to 3 other carbon atoms, then that carbon will be what? 3-degree carbon or tertiary carbon. And here also we have tertiary carbon, 3-degree carbon. So branched chain of carbon atoms containing at least 1 tertiary carbon can be named as isoalkanes. Then what are isoalkanes? Isoalkanes only 2 conditions. One is, what are the 2 conditions for isoalkanes? One is they containing branched chain of carbon atoms. Second one, that branched chain containing at least one tertiary carbon. Then how to define isoalkanes? Isoalkanes are nothing but alkanes containing at least one tertiary carbon, 3-degree carbon in a branched chain of carbon atoms are called isoalkanes. Then how to name these compounds then? Since they are containing 4 carbon atoms and the carbon chain is branched and they are having at least one tertiary carbon, the name of this compound is, what is the name? Isobutane, and this is isopentane. What is the prefix that we had to use? If a carbon chain is branched and that branched chain containing at least one tertiary carbon, remember the condition, we can use the prefix iso only when carbon chain is branched. Not only that, it must containing at least one tertiary carbon. Then we can call those alkanes as isoalkanes. So isobutane, because carbon chain is branched and it containing one at least tertiary carbon, and this is isopentane as it containing tertiary carbon. But as I said, propane, we cannot branch the propane here. The reason for that is minimum 4 carbon atoms are required to branch a carbon chain. And the carbon chain branch agbeku andre minimum 4 carbon atoms beku. Okay. So this is about the second types of alkanes under common name system. We are using prefixes while naming the alkanes as N and iso. N stands for normal, iso stands for branched chain of carbon atoms, and that branched chain containing at least one tertiary carbon atom. And the last one is, the last category of this is neoalkanes. Third one is neoalkanes. Neoalkanes. What are neoalkanes? To give this neoalkanes, so to give isoalkanes, minimum carbon atoms will be 4 carbon atoms. Isoalkanes that we can name only when if alkane containing minimum 4 carbon atoms, and if you want to name neoalkanes, minimum 5 carbon atoms are required. So neoalkanes name can be given for those alkanes which are having 5 and more than 5 carbon atoms. So then what is the example? CH3, CCH3, CH3, CH3. 5 carbon atoms are there. Let me write the carbon skeleton of this compound. This is the carbon skeleton of this compound. Now, 5 carbon atoms are there, and is the carbon chain is branched? Yes, the carbon chain is branched. Now, in both isoalkane and neoalkane, the carbon chain is branched. But how to distinguish iso and neo? In iso, the branched chain containing at least one tertiary carbon, whereas in neo, the branched chain containing at least one 4-degree carbon. 4-degree carbon. What do you mean by 4-degree carbon? Quaternary carbon. Quaternary carbon. Okay. What is the difference between isoalkanes and the neoalkanes? So in both the cases, alkanes containing branched chain of carbon atoms, but in isoalkane there must be one tertiary carbon, whereas in neoalkanes the branched chain of carbon atoms containing at least one quaternary carbon atom. 4-degree carbon. See here, this carbon is bonded to 4 other carbon atoms. So if a carbon chain containing at least one quaternary carbon or a 4-degree carbon, then you can use the prefix neo before the name of the alkane. What is the common name for this? Pentane. But we are using here neopentane. Neopentane. Why it is neopentane? Because it containing one quaternary carbon in a branched chain of carbon atoms. Now let me give one more example. CH3, 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 CH2, CH3. Now how many carbon atoms are here? 6 carbon atoms. Write the carbon skeleton. This is the carbon skeleton. The alkane containing 6 carbon atoms is named as hexane, but it is a neohexane because, why it is neohexane? Because it containing 1 4-degree carbon, quaternary carbon. Hence the name of this compound is neohexane. Neohexane. Then how to define neoalkanes? These are the alkanes containing at least 1 quaternary carbon or a 4-degree carbon in a branched chain of carbon atoms are called neoalkanes. So on the basis of common name system of alkanes, we can classify the alkanes into 3 types by using the prefixes N-alkanes, isoalkanes, neoalkanes. What are N-alkanes? The alkanes which containing straight chain of carbon atoms, and isoalkanes, alkanes containing at least 1 tertiary carbon in a branched chain of carbon atoms. Neoalkanes, the alkanes which containing at least 1 4-degree carbon or the quaternary carbon in a branched chain of carbon atoms are called neoalkanes. So isoalkanes are named only for those alkanes which containing minimum 4 carbon atoms, and neoalkanes with 5 or more than 5 carbon atoms. So these prefixes of the common name that we are using in isomerism. So isomerism concept ಬಂದಾಗ ಈ prefixes ಬಹಳ important ಆಗುತ್ತೆ. N-butane, isobutane. We can classify these two as chain isomers ಅಂತ ಓದಿರ್ತೀರ ನೀವು. So while giving the chain isomerism, these prefixes are very important for naming the compounds. Okay, so this is about the common name system or the trivial name system. So the second system is nothing but IUPAC system. IUPAC system. So in the next class, let us consider why this system is introduced for naming the organic compounds. Why IUPAC system of naming the compound is introduced for naming the compounds. Thank you.